Hello friends, welcome to Technopoints. In this video, we are going to learn about solid principle in object-oriented design. So solid principle are the principles that we should take into consideration while building any large software using object-oriented language so that our software becomes more maintainable and adding new functionalities to it becomes an easy task. Besides this topic is also important in the interview point of view because I had a lot of interviews till date, and in from those about 90% of interviewers had asked this question. And as I was able to explain them well about all of these principles, their feedback was positive. So watch this video till the end so that you will grasp all these concepts and you will be able to explain your interviewer at the time of your interview. Also at the end, I'll be sharing you one bonus which will contain a short summary that is notes of these all solid principles. It will be helpful when you are going for an interview and you want to prepare this concept. It will be just a 5 minutes of reading and you can just read it in 5 minutes and you are ready with this concept. So make sure you stay till the end for the bonus, and for now let's get started. The first principle starts with S and it stands for single responsibility principle, and it states that every class should have one and only one responsibility. It means that one class should execute only one functionality and it should not have more than one responsibilities of executing this and this thing also. So let's move to our ID to understand this. This time I am not in Android Studio. I am in Eclipse IDE. So basically in Eclipse IntelliJ IDE. So we don't necessarily need Android Studio for this. I just wanted to make this concept understand to you. So first one is single responsibility principle. So in this, I have created one class named one file named single responsibility. In this, there is one class network calls. Let's say we want to make network calls in this class, and login is one of the network call which we need to make, and it has a one function named a login. It is accepting username and password as the string parameters, and here it will execute the login logic whatever it has. But here is a try catch block because the login might fail or the connection might fail. So here is a try catch block we have, and in the catch block what we are doing, if there is some error, then what we are doing, we are executing the logic to log this error to, let's say, we are using the Firebase analytics for that, and we are logging this event when there is a some error in the connection, or making some connection becomes an error. So this task we are doing. So basically this class has become now two responsibilities. It is responsible for two things. First one is network calls. Login is the network call, and if that network call fails, then it also has to do this thing of logging the particular event to the Firebase console. So this is the violation of the first single responsibility principle. For to avoid this violation, what we can do is we can just create a separate class of this named as analytics, and we can just make all this logic inside one method here. Let's say log error, and here we'll paste all that logic, and we can just accept a message here, or error code, and error code message will be of a string, and error code will be of type, let's say, integer. So will just assign this as message and error code to this analytics. It will be a class of, let's say, Firebase analytics. This is showing as an error because this is just for demonstration purpose. There is no such class included in our project, and this is just for demonstration purpose. So we'll execute all this logic here, and from here we can just create it as an object, or just a companion object, and we can just directly call this method from here itself, that is analytics dot log error, and we can just send a message like something went wrong, and we can just pass a error code as a let's say 404. We are passing some error code. So in this way, we can avoid the violation of first principle. That is about single responsibility principle. Now let's move towards another principle, that is open close principle. So this O stands for open close principle, and it states that the class should be open for extension but should be closed for modification. Let's say we have one class which contains one functionality and we want to extend that functionality. So instead of making changes in that existing class, we what we can do is we can just create another class inherited from that parent class, and we can add their functionality here. So let's go to ID to understand this concept. So here I have created a one open closed file here. In this I have created one login utils here. Let's say here it is a function login to app. So basically, this class is responsible for all the login utilities, and it we have login to app which accepts username and password as a string, and it performs some custom logic to login the user. So there can be another alternatives like login with Facebook, login with Google. This type of alternatives, alternative logging mechanisms can also present. And at starting we haven't included those. Now we want to add those things in our project, in our that class. So here, instead of changing the contents of this class, what we can do is we can just create another class. I have created another class here with a login with alternatives, which is inheriting from login utils. For inheriting, I have declared this class and class as an open. For this login, and I have created a specific method, special method for this login with Google. Here it will implement a login with Google account logic, and here login with Facebook, and we will do the same with the Facebook here. Login is Facebook logic. So in this way, we can just refer to this class in this main method. Let's say we can just create a object of this login with alternatives. Login equal to login with alternatives, and we can access any method defined here. Login dot sorry here is it is capital. Login dot we can now access all the three methods. Login to app, which implement the custom login logic, and login with Facebook, which contains Facebook to login logic, and login with Google, which contains logging with Google account logic. Now we are in this way we are adhering to the open close principle. If we have made changes in this way class itself, then we will be violating our open close principle. So this is how we can stay adhered to the open close principle. Now third principle starts with L, and it stands for Liskov Substitution Principle, and it states that objects of a superclass shall be replaceable with objects of its subclasses without affecting the correctness of the program. So what this actually means, let's go to our ID to understand this. So here I have created one file named as Liskov Substitution, and here I have created a one class as a vehicle. I have made this class open so that any class can inherit extend this class. So this is the vehicle class. It contains two functions. First one is a max speed, second one is a fuel type, and these are the default values of this one of this vehicle class, that is 150 and diesel. Now I am creating another class named as car, which extends from vehicle because car is also a vehicle. So we are overriding these two functions as a max speed and a petrol. Now car can also have 200. Okay, so I have created overriding these methods, and I have created my own version of the car related to this for this vehicle class. So this returns 200 and this returns fuel type as a petrol for this. But the third class is I have created as a cycle, bicycle or cycle we can say, which also exists from vehicle. Yeah, it's also a vehicle. And for the max speed, yeah, it also have a max speed. But if we are going to override another class, another function that is of fuel type, of which function is present in the vehicle class, then it violates this principle, because cycle or bicycle doesn't need any fuel. So I haven't implemented this method here. So in the main function, what I have done is I have created a class named vehicle, and also created a class also created a object of class car, and also object of a bicycle, a cycle. Let me correct this, cycle. Now this car dot max speed, I want to get the max speed of the car. Yeah, that's fine. I want to get car dot fuel type. Yeah, that's fine, I can get that. Now in case of this cycle, cycle dot max speed equal to 40, that's fine. But if I click on cycle dot fuel type, then cycle don't have any fuel, and that's why I haven't overridden that. And now if I click on fuel type, it will go to its vehicle class. If I control click, it is coming as here, and it will use the method of its parent class. If this method fuel type is not present in the bicycle class, then it will automatically inherit the method fuel type from our parent class, and that will return as a diesel. That will mean as a bicycle is running on a fuel diesel. That is totally wrong, that doesn't make any sense. That's why we this is the now what the principle is says, vehicle dot max speed. Let me put vehicle everywhere. Vehicle is there. Now this is the object of a superclass. Now let's again go to our slide to understand what the principle was stating. Principle was saying that objects of a superclass shall be replaceable with objects of its subclasses without affecting the correctness of the program. Objects of a superclass. This is the object of a superclass. Vehicle is a superclass here. This is the object of a superclass. It is saying that shall be replaceable with objects of its subclasses. Now, if I want to replace it, there are two subclasses of the vehicle here. First one is a car, and second one is a cycle. So I will replace this vehicle with a car, and this also with a car. Then it doesn't it makes sense. I mean, it doesn't make any issues with that, because car can also have a max speed and car can also have a fuel type. Now in this case, here is a vehicle, that is a superclass, and let me put a cycle here. Let me replace this object of a superclass with object of a subclass as written in the slide in the principle. I am replacing this with the cycle, both of these things. Now I have replaced the objects, but the functionality got affected. What it is saying that it should be replaceable, but without affecting the correctness of the program. But it is affecting the correctness because cycle doesn't have any fuel, and that's why it is violating. It is, I have written here, is the LSP violation. That's why LSP is getting violated here, because cycle doesn't have any any fuel type. If I had to implement this method, override fuel type, then what I need to do is, as it doesn't applicable here, I can just write return unsupported operation exception. I can throw unsupported operation exception. So I can implement this method like this, but this method will also be of no use, because if this method is called, then it will throw an exception. So this is the violation of Liskov substitution principle. So this thing should not happen in our software architecture, because of the cycle don't need this fuel type, so that we can create a different, we can inherit that, or we can create a different uh, parent classes. Like in vehicle, we can also categorize further vehicles with the fuels and vehicles without fuels. Then we can create other classes inheriting from these parent classes. Now this fourth principle starts with I, and that stands for interface segregation principle, and it says that a class should not be forced to implement the function of an interface which it does not need. That actually, this statement actually makes the sense that there is one interface which we will be implementing in our different classes, and out of those, if some classes don't need that functionality, then also it should not be forced to implement that method. So let's go to our ID to understand this. So here I created one file for interface segregation, and here we have created a interface here. It is named as a shape. Okay, here is a calculate two methods for the interface: calculate area, which written as an int, and calculate height, which written as an int. Now I have created a separate class named as rectangle, which implements the this shape interface. So it compulsory have to implement all of these methods containing that interface. So this calculate area and calculate height, both of these method has been overridden uh, by, by by this class. So there is no issues with that. So we can calculate area for this respective rectangle, and I am just returning this some random value is 30 here, and here is a calculate height. What is the height of this? Or for the height, instead of height, we can also rename it as a length. Okay, length. It will make more sense. Length. So length will be 100. So that is also fine. Now we have created a circle here, a circle class here. So it also implementing the shape interface. Now as it is implementing, it also has to implement these two methods also, like calculate area. That is fine for the class or the circle. Circle has an area, that is fine. But here there is a forced implementation for this calculate length. Now circle can't have any length. Circle can have only radius and diameter. So this thing doesn't make any sense. And here I have written like throw unsupported operation exception. Instead, if I don't need this, then I can just rub it. But no, this is forcing me to implement. It's showing an error here. And if I click alt enter here, implement members, I has implement this method, and we can, if I had to implement, then I can just return a 0 from here, because this method will never be called. So this is the violation of the interface segregation principle. Instead, what we can do, we can create a different interface, like calculate like area and length. We can create separate interfaces and then implement that in the separate respective classes. So that will not happen this issue. Now this last one starts from D, and it stands for Dependency Inversion Principle, and it says that we should depend on abstraction rather than concrete implementation. Whatever the functionalities we will be embedding in our application, that should be using abstraction rather than concretely implementing those. Now go to ID to understand this. So here is the file I have created for the dependency inversion principle, and here I have created one class states that custom login. It is named as custom login, and it is implementing this interface login methods. So this version I have already taken care of the dependency inversion principle. So for this, what is stated that we should depend on abstraction rather than concrete implementation. Let's say I only have this class. Ignore error first now. Let's say I have this custom login class and it doesn't implement any interface here. Okay. Let's say I have one method, login being my favorite example. Uh, Now login with email and password. It is accepting username and password for that, and here we will be going to implement a custom API login logic. Now if we want to extend the functionality, then what we had to do, we need to make changes in this, make a lot of changes. Like there is also different authentication, like Firebase. If you are using Firebase database later on, then we also need to include that logic in the same class itself. And this is extending the class, and this is increasing the number of modifications in the existing class. So instead of doing that, what we can do is, we have created a separate interface here, that is login methods, in which I have just declared a function here, login with email and password, which is accepting both username and password. Basically this is what we want whenever we want to do a login operation. So this method is accepting username password from both of these classes. I have created separate classes, custom login and login with Firebase. Let's say we will be using we are using Firebase now for the login. We are using, let's say we are using the both or either one of them, and this custom login also implement this interface, and this login with Firebase also implement this interface, and we are overriding this login with email and password method, and we are accepting the same number of parameters here, but here we will be executing a different logic. Here we are using implementing a custom API login logic, and here we will be implementing a login with Firebase API logic. So as we are now depending on this abstraction, so our modification becomes easy, and whatever the class I have created just now was an concrete implementation of the login and registration. Maybe not registration, because if you had a class like that, then it was a difficult task to keep the existing functionality as it is, and then again make some conditions like on some flags, and then implement the other logic in also in the same class and in the same method probably. And if we are implementing if we are using this dependency inversion principle, then we, as we are depending on the abstraction, we don't need to make any change into this class, we don't need to make any change in our interface. We only need to create a separate class and extending the same implementing the same interface, and we are also implementing the same method here, but just the logic will be different. This makes our modification very easy. So this is the main goal of this dependency inversion principle. This is how all these five solid principles work. I have tried my best to explain with the help of respective examples. If still you have some doubts, then you can just drop your comments in the comment box below. I will try my best to answer those. Now, coming to the bonus part. In the bonus, you will get the short notes for this all of these principles, also the slide which I have just showed in our tutorial. You will get both of these things. For that, you only need to do small tasks. In the description, I have mentioned my Instagram handle, that's Ashish Mobile Dev. You just have to follow me there and just put a message me saying I want the bonus of this solid principles tutorial, and then I will share with you. Again, if you like this video, then please click on like, share with your friend, and don't forget to subscribe to this channel so that whenever the new video is published, you will get notification for that. We'll meet in the next tutorial with some another interesting topic. So till then, goodbye, happy coding.